In this case, we want to calculate the volume of solids formed by the rotation around the x-axis of the figure bounded by the following curve. So we need to find the volume of rotation. And in particular, we have two curves here. Let me sketch below. Y equal to x squared is a parabola which does something like this, and then the curve y squared equal to x is something like this. So we have x equal to y squared. We can also read it like that, x equal to y squared, which means y equal to plus or minus the square root of x. So y equal to square root of x is something like this, whereas y equal to minus square root of x is something like this. And the figure that's bounded by the following curves is, the area that's contained is delimited, let's say, by the two curves is this. We need to find this area, and in particular the volume generated by this area. So you have to think that these two curves together will revolve around the x-axis, and they will create a volume. So how do we find the volume? Well, when we have a curve like this, and this is the xy plane, so we have a curve, let's say f of x, and this height of the curve here, this is the y coordinate of the curve, is equal to f of x. And if we rotate the curve around the x-axis, we are going to generate some volume here. And these slices, these sections of the curve are circles. So we have circles here. And if we sum all the areas of this circle around, of these circles around along the x-axis, we are going to get a volume. So the area of the circle is pi times the radius squared. In this case, the radius squared is simply f of x squared, right? So we have pi f of x squared is the area of this circle. Then we integrate over the x and we find the volume in this region here. So we have to do something similar here, but we have two curves. So we are going to first find the volume which is enclosed by the outer curve, and then we are going to subtract the volume that's enclosed by the second curve. So we have to use a subtraction here. We have to make a subtraction in order to find the volume that we want. And in particular, we also have to find this point where the two curves are equal. So we have to set x squared equal to the square root of x, because this is the point where this upper part of the curve is y equal to the square root of x. So this is true when x is equal to either 0 or 1, but this is the other point. This is the point x equal to 0. The other point is x equal to 1. So we have to integrate from 0 to 1. The first integral that we have to carry out is pi, and then we have f of x squared, which is this first curve here, which is the square root of x. We have to square it and integrate over the x, and then subtract the integral from 0 to 1 of pi x squared dx. So this is a simple integral to carry out. We have pi times x squared over 2, and evaluate it between 0 and 1, minus pi x to the 5th divided by 5 from 0 to 1. So we get pi times 1 half minus 1 over 5, which gives me pi divided by 10 here. Then we have 5 minus 2, so it's 3 over 10 pi.